Alright guys, I've got this amp here which has got a bit of a no power up problem. This is one of these fancy surround sound amp things. As you can see, it's pretty substantial and it's got a considerable number of connections on the back. It's got 7 speaker channels and God knows how many inputs, digital and analog. It's a pretty scary piece of technology. Inside you can see here the main amplifier board, and as you can see, 1, 2, 3, 4, 5, 6, 7 channels, all identical with these big 5-watt power resistors here. Fairly standard push-pull design, and 7 channels. Some big reservoir capacitors hiding under there, 63 volts, I think they're 680 microfarads, and a variety of these horrendous logic boards, incredibly complicated, fiddly, and almost certainly encrypted stuff. Rather impressive looking heavy duty power transformer there, so very nice electrostatic shield going around it. Standard sort of center tapped output plus a variety of secondary and tertiary windings for standby and so on. Anyway, let's just take a look and see what happens when it powers up. Let's apply power, and let's see what we got. We've got a standby power light on the front, so we'll give that a push and see what happens. Got a relay click, second relay clicked, and we've just got a flashing light. It's obviously trying to power up, but it's obviously found something's not quite right. Let's power it off. And the relays click off. Yes, something's not right. Oh, oof. Oh, okay. That's not good. Oh God, that smells dreadful. I'm not quite sure what actually popped. That's interesting. Right, that's the amplifier part. So you can see the main amplifier board here, a couple of big reservoir capacitors, and then we've got 7 replicated amplifier channels. I think this is a 5.1 or an amplifier, I'm not sure, maybe 7.1, but the bass, the subwoofer, isn't amplified and it just has a line voltage output. I think that's what it is. And this is it's this second channel here that's failed, and you can see, well, probably not very well on the video, but there are a couple of blown capacitors here. This one's vented, that one's vented, that one's bulging a little bit on the bottom. And in here, so you've got these 2 transistors here, and in between them you've got another small transistor connected thermally to the bigger transistors. Now, so I don't know if we'll be able to see that on the video. Probably not, but you can just see there's a little spot of heatsink compound there attaching a small transistor to the larger ones. And on this one here, the transistor has basically been disintegrated. There's nothing left. So there's obviously been some sort of catastrophic failure here. This circuit here, where you have a small transistor thermally attached to the larger ones, is fairly common. It's a fairly common method of biasing transistors in amplifiers. You want to have a small enough voltage difference between these two so that they're both conducting at the same time, albeit not completely. You want to have a small amount of idle current running from positive to negative. just enough to get the transistors into their linear range, and it's what's called a Class AB amplifier. And common way of doing it is what's called an amplifier diode, which is basically a transistor attached to a voltage divider pair of resistors, and you can see the trim pots here, and that's a very standard configuration. And because transistor bias voltage changes with temperature, you have the amplifier diode transistor thermally connected to the push-pull transistors. So it looks like this is just an initial push-pull stage, and then you've got the output stage here with these big transistors, which is probably connected again as a push-pull pair or possibly emitter follower, but we'll find out more once we get a little bit further on. You can see back here there's a sort of a power stage. Move the camera a little bit. It's quite scorched here, it's obviously been getting very hot. This looks like the 15 volt plus or minus 15 volt stage for the preamp. Been getting very hot, probably a Zener diode type arrangement. A few other scattered capacitors here, a few various inputs, analog inputs here. Again, not surprisingly, this is an analog board. Couple of bridge rectifiers here on this heatsink here, and a couple of relays there. And this is the line level, I think, voltage output. And interestingly here, number 2, number 3, let's have a look. Well, actually, let's have a look at this board here. This board here is the actual speaker output board, and you can see it's got these sort of hose pipe connectors. I don't know what the proper name for those are. You can see the output selection relays, protection relays, and then you've got these connectors here, which I've just labelled up, 2, 3 and 4, just in case I wanted to put this thing back together again. But I don't think that's going to happen. That amplifier board is toast. And what's interesting here is we take these cables here from the amplifier board, here number 3. Well, these are your speaker cables. So I often see all these audio fools talking about their semi-crystalline monodirectional speaker cables. Well, if you look inside your amplifier, this is the speaker cable here. This and this are your speaker cables. So your monocrystalline, semi-directional, gamma shielded, whatever cables. Well, you just got these. They're not going to do much when you've got a good foot or so of this ribbon cable in there. Okay, but if we come back to this, it's quite nice, really. So we've got our control signals here from the microprocessor board. We've got these little driver transistors here, which are used to drive these relays, and these relays select the outputs. So it's actually quite a nice little board, and we've got some quite nice filtering here. We've got some little air core chokes and capacitors and various bits and bobs in there to try and prevent, mobile phone interference from tracking back into the amplifier. Fairly standard single layer board, pretty nice. Might be some nice parts on that. What are the other parts? Well, let's grab this thing. First of all, let's start with this bit. This is the HDMI board. So we've got 5 HDMI ports there, 4 input, 1 output, and if we look at it, we might be able to see something interesting on here. So we've got a Texas Instruments DSP, again Dolby Digital and DTS capability, and then we've got this silicon image vast lane HDMI input multiplexer, and there's another silicon image vast lane output driver there. Probably looks like power supply circuitry here. We've got some transistors, a few capacitors and stuff. DPAC, these could be regulators of some kind. Bit of expansion flash memory there, and that looks like a Samsung DRAM, and a few other bits and bobs. But actually, these little candle electrolytics, it actually doesn't look too bad. been a bit of hand soldering there. And that then connects to this board. This is the component video input board. I have to say I don't quite understand what this thing does with component analog input. Big bridge rectifier there, big capacitor, a couple of 7805 regulators here, various capacitors and stuff. This little riser plug, which is some sort of proprietary control interface, and connector there to the main digital microprocessor board. Not terribly interesting thing. Obviously something's got very, very hot there, and this is some sort of ASIC. I don't know what it is. It's marked JRC NJW1326F. I don't know what that is. Probably some sort of digital signal or analog multiplexer or something. What's this? This is your radio tuner module, so FM AM radio. It's in this nice little can. Let's pull the top off, see what we got inside. It's just one of these monolithic things, isn't it? There's a little IC on there. AN18208. Don't know what that is. Well, we'll take another look at that. It's not very interesting. So this is the main microprocessor board here. So there's an NEC something on there. I can't actually read the markings. Some of them have come off, it's been hand marked, very difficult to read. And what else have we got? Cirrus Logic, codec there, crystal for the codec, and a few other bits of what look like glue logic or something like that. And on the back, very little to see really. Fairly nice looking board, quite dense signal tracers, you know, capacitors and stuff. Yeah, looks quite nice, quite interesting. Okay, so that's the bulk of it. Nice big heatsink here. Let's move the camera a bit. Lovely heatsink there. That might be useful for something, so don't want to throw that away. And we've got this lovely transformer here. Oops. Lovely transformer here. Big, nice output cables. Copper electrostatic shield. Looks nice. And our little standby power board here is a little tiny capacitor in there. Not capacitor, what am I talking about? There's a little transformer here for standby power, relay, a few other odds and sods. That might be interesting. Well, that's it for now. I might see if we can get the front panel out and take a look at that. Okay, we've got the front panel off. So Onkyo, power button, that's what caused the blow up, standby, a few little LEDs there, pure audio. Don't know what that means. I think that turns off all the digital processing. You know, various little sort of selector buttons, menu buttons, so on. Nice big volume knob there, motorized of course. A few little front panel connectors. On the back of it, you know, fairly straightforward layout. Board there. Some sort of microprocessor or ASIC there. And your power button board there, jump cable. So all of this was working, but something blew up in the amp. And this is quite nice. Pretty much most of the boards have this on them. Little screen printed legend next to each connector telling you what each wire does. So here we go. Number 1. Ground, 2 auxiliary voltage, 3 analog ground, 4 left, I don't know what that is, left input, left auxiliary, 6 right auxiliary, microphone mute, microphone detect, plus 15 volts. It's all pretty interesting stuff. And it's the same also with many of these other boards here. So, you know, if you look at this one here, which is the speaker outlet board, again, next connector I've labelled 3, you can actually see 22 volts, ground, subwoofer, SRE, I don't know what those, or maybe it means surround, I don't know. Right E, C-E-L-E, I think that means right earth, centre earth, left earth. And up here on connector 2, speaker, SBL, sub left, I don't know, SLLCR, SR, so that must mean surround R, surround left, surround rear left, surround rear right. So speaker here, speaker earths here. Number 4, some sort of surround, I think. I'm not quite sure. But you know, you can kind of work out what these things do, which is quite handy when you're working on something like this. And I'll just have a look at the back plane here. The back plate, you know, that's a serious number of connectors there. Just look at that. That's serious. This is serious amp that. But I'm told that this is fairly standard on this sort of piece of equipment these days. Nevertheless, it's a pretty serious piece of kit. Okay, and this is the transformer. This is a pretty serious transformer. Onkyo high current power supply. So you can see this lovely copper electrostatic shield going all the way round. Very nice. But I don't think these are supposed to form a complete turn for fairly... Oh, no, I see. It goes outside the core. Obviously, if this shield went through the core, then you'd be in trouble because it would just be a short-circuited lead. The short-circuited turn, sorry. So I wondered how they did that. I've not seen that before. Anyway, pretty serious piece of kit. This looks quite nice. Don't know what voltage it is, but I'm guessing it's probably sort of in the region of 30 or 40 volts. Looks quite nice. I suppose we could plug it in and try it. Looks pretty nice. Okay, this is the back of the amplifier board. So here, just behind this thing on the is where the capacitors are. You can see the legs of the capacitors here. And this is a big slab of copper here, and you can see the star earthing here. So you've got the individual earths to each individual amplifier here. If you turn it over, you can see the 2 bridge rectifiers there. I don't quite know what's going on. Let's have a quick look here. Yes. Not quite sure whether they're in parallel or not. I suspect they probably are. Relays and some slow glow fuses there. All part of power control circuitry. Let's see if we can take a look here at this blown amplifier. It's about as close as I can get, I'm afraid. You can just see the domed capacitors there. The main output drivers are Toshiba A1941 and C5198, matched NPN-PNP paired bipolar transistors, fairly standard stuff for audio amplifiers, pretty commonly used. Got your thermal sensor there on the main heatsink, and as I mentioned earlier, here on the bottom of the heatsink you've got these little transistors. These are the bias transistors for the main output drivers. Again, some sort of unmarked or not very clearly marked chip. Again, probably something to do with input selections, probably an audio multiplexer. If you look at the traces here, it goes to all the various analog inputs. So this is probably the analog multiplexer or demultiplexer or selector or whatever you want to call it. 7815, 7915 there. No, yeah, 78 and 7915 there. So that's your plus and minus 15 volt supply. All pretty standard stuff, really. But yeah, this amplifier here, number 2 on that side, and it says SBL, which I think stands for back surround back left, has blown. There's obviously been some sort of catastrophic failure, and I suspect one of the semiconductors in here is blown, and it's putting voltage where it shouldn't be, and you've blown the capacitors due to overcurrent or reverse voltage or something. So there we go. Yeah, so there we go. Pretty complicated, pretty substantial piece of kit. I don't know how much one of these costs new. I'm guessing probably £300 or £400. And you actually get quite a bit of kit for your money. I especially like this Jesus, this thing's heavy. This transformer is pretty nice. Very heavy. Big iron core. I suspect, like a lot of audio transformers, it runs at low flux, so the core is oversized. And this gives you less magnetostriction and less vibration, and it also avoids problems like inrush current. Inrush current in transformers comes from core saturation, and if you oversize the core, you can actually avoid that completely. So you can buy audio grade oversized toroidal transformers which don't have a certain inrush current. And a variety of windings here. I think the main output ones are plus and minus 22 volts or plus and minus 20 volts. So there we go. That was the digital audio receiver. Hope you found that interesting.